Step 1. The marble is placed in the center of the platform, and the marble is at rest. At its initial position at
0.43 meters,
the marble is at its highest position and therefore has its maximum
potential energy.
Potential energy is equal to mgh. Kinetic energy is equal to 1/2 mv squared. Step 2. Once the motor is connected to the battery, it starts to coil the string around the axle. The string is connected to the platform, slowly pulling it down to start the contraption. The pulling of the string creates a tension force that extends the string with a certain force. This is where the potential energy is converted to kinetic energy, as the marble rolls down the now inclined plane into the funnel. Step 3. When the marble falls into the funnel, it circulates around the funnel. This is a representation of a circular motion, which is accelerated gravitational motion by the central pedal force. Acceleration is towards the center of the funnel, and the velocity is perpendicular to the acceleration vector. Step 4. The marble then rolls through the funnel into a step, which is a paper plate stuck into the cardboard at an angle. Once rolling at a certain velocity down the step, the marble falls into 1 cup of the catapult. Once there is enough weight in 1 cup of the catapult, a smaller marble with less weight will fling out of the catapult, resulting in a projectile. In terms of the circuit diagram, the battery, which is around 9 volts, is connected in series with a DC motor, and once the wires, which are the copper wire, touch the battery, there is a flow of electrons to the motor, which allows the motor to start rotating. For the math, we decided to discuss the concept of how energy is conserved in the contraption. We made sure to measure the following: the mass of the marble in kilograms, the height from the surface of the platform to the marble in meters, the time it took the marble to reach the bottom of the contraption for 3 trials in seconds. Using the concept of conservation of energy, 1/2 mv final squared is equal to mgh plus 1/2 mv initial squared. After finding the final velocity, we also figured out the acceleration the marble had leaving the contraption by using the formula v final squared is equal to v initial squared plus 2ad. We know the final velocity and the initial velocity is equal to 0, and the d is measured to be the length from the beginning of the contraption to the ending point that the marble landed on. We found the acceleration to be
15.95.
Now, to end off the video, we would each like to say a few words to you, Miss M, and how your class has shaped our lives. Even though Physics 2 may not be my strongest subject, I always wanted to know more about it. This past year, Miss M has taught me a lot about how something like fluid dynamics can be applied in the real world. Like in medicine, where a patient might be experiencing immense pain in an artery due to high fluid pressure. I hope that this knowledge will help me in my future.
This year, this class was so much fun because I got to meet a lot of people, she got to meet new people, and now we're great friends and it's a good time.
And the labs were so fun. Thanks for an amazing year. Have a great summer.
Bye!